Welcome to For the Love of Nature, a podcast where we tell you everything you need to know about nature and probably more than you wanted to know. I'm Laura.
And I'm Katie, and today we're going to be talking about poisons and venoms and how, although many things in nature can kill you, these adaptations ensure their species survival. AKA, there's a lot of crap that's gonna kill us all.
Deadly stuff. But really cool. Like this, the more I was reading about this, the more I was like, man, this is fascinating stuff.
It was, and it was like a lot more detailed, like just so much more than what I thought it was going to be. Like I figured it would be a little bit more cut and dry, some of the different categories and everything that I was going through, but it's more complex the more I dig into it, which is interesting.
Yeah, same. And like as I was reading too, a lot of it was talking about like with venom specifically is the evolution behind how venoms came about. Mm-hmm. And again, that's like a whole nother rabbit hole that I was like starting to go down and then was like, no.
Which is interesting because I'm going to talk a little bit about that, but it's total opposite of yours. Wah, wah.
Cool.
Alrighty. Do we want to start with nature news?
Yeah, I heard you got some.
I do have some because it is the Curiosity Mars rover's birthday this month.
Woo!
10 years ago. Can you believe that? 10 years ago. The Mars rover. Like, that doesn't seem...
No, I mean, I can't...
That it landed on Mars. That doesn't seem like it was that... Yeah. I'm telling you, yeah, 10 years. 100%. 10 years ago, a pioneering mission...
Recently.
The telescope was launched.
Mars happened recently. No.
But I mean, it's been finding stuff. Like, it found water beneath the surface and things like that. But yeah, it celebrated its 10th birthday. I remember when it first launched, and I was like, oh, man. And I can't remember how long it took to get from here to Mars. But I remember being like, man, that's going to be forever before we see stuff. But clearly, not that long. Because, I mean, here we are 10 years later. Totally forget about it.
So it launched 10 years ago or landed?
It landed 10 years ago. So it's its landing birthday. So what is the Curiosity? If anybody doesn't know, it's a rover, a little robot on wheels, I guess you could say, that we launched and landed on Mars. And the main objectives of the rover is to discover if Mars ever possessed the right environmental conditions to support existence of simple life forms, aka any microbes.
Which, shout out to our astrobiology episode.
Yeah, right?
Could be. Kind of seems like it could be.
Yep. So the rover itself is about a car size, so it's pretty big. And it's about this is such a weird, so this is from, again, that science app, the Science News app.
Oh, yeah. But
it says that it's roughly a car size, and it's as tall as a basketball player, according to NASA. How do you, okay, I get it's like roughly car size. Okay, like, yes, there's a variety of cars, but generally the gist of it. But as tall as a basketball player, I feel like that height varies significantly. Like
a Hummer.
Yeah, right? I guess. Anyway, but it's collecting rock, soil, air samples, it has a 7-foot-long robotic arm, and it's just been kind of cruising around looking for literally anything and anything it can find just to see if there's any organic carbon compounds within rock, soils, or any other organic molecules that could have either now or at some point served as building blocks for life on Mars. Yeah. I don't really know how far it's gone. I don't think it's really said.
It's crazy to think it's just like car size seems pretty big, but then when you think about like it's on a planet all by itself.
It's
you're like,
fending by
itself.
itself.
Got a lot of ground to cover.
Yeah. Poor little spacecraft.
A feral rover.
Yeah. But then at the same time, it's like WALL-E. You know what I mean? Yeah. Just all by itself.
This and this. It's just like real OCD about collecting everything.
Yeah, right? Yeah, it doesn't say, I don't know how far it's gone so far, but anyway, yeah, they could. I know it did find that it showed that there was at one point water beneath the surface and stuff like that. So, but yeah, happy birthday!
Like water is one of the essential things for life. So if water exists, then possibly we could find evidence.
Or if anybody watches Apple TV's For All Mankind, which is a fantastic show about space. It's like a what is it? Like one of the history bending ones where it's like things that gets changed history like as an alternative. Like if we didn't land on the moon first, if Russia landed on the moon first, what would that trajectory of the world look like? And it's really, I mean, it's fascinating. I think they did a really good job. Anyway, this season they landed on Mars. Spoiler alert. Like it's on all the advertisements. It's literally Red Planet. You can't really mistake it for anything else. But so they talk on there. They do a really good job, I think, from like a science perspective and everything. I think they do a pretty good job. But it's interesting. For All Mankind. But they're on Mars right now, trying to get off of it. Because it's a show, so of course they're going to do something stupid. So, speaking of stupid, do we want to talk about poisons and toxins? Because a lot of mine... Stupid. No, not like the stuff. I'm talking about stupid people.
Oh, okay, yeah. I mean, yeah. As we talk a lot about, nature is something that needs to be respected, and the more I read about this, the more you're like, yep, gotta know what you're doing when you're out there in the wild, because you could die.
Yep.
Okay, yeah, sure. So, as we said, everybody, we're gonna talk about, our episode is called Toxic Nature. So, first of all, what's a toxin? A toxin is a substance created by a plant or an animal that is poisonous and or toxic to humans and other animals. Toxicity is measured in its effect on an organism, tissue, or cell. Okay, so lethal dose 50 is kind of also known as the median lethal dose. So that's how toxicity is measured. Basically, it's when scientists give animals a certain dose of a toxic substance, and once 50% of them die...
Oh, 50%. Oh, wait, what?
That is the median lethal dose.
Wait, hold on.
Pretty messed up.
How do we figure this out?
So they just start little bits, more and more and more and more and more and more and more, and then boom, lethal dose 50 is when 50% die. So that is the level of toxicity that, in general...
Is it accidental? Because I figure they wouldn't be like, hey, Fred, come here, Fred. You know what I mean?
Yeah, no, apparently, I mean, nowadays they're doing it on, mice and lots of other kinds of animals, unfortunately.
Of course.
Yeah, poor things. But, so that's how all toxicity is measured from, I'm pretty sure it even said medications and things like that. What is a toxic dose? LD50 is the shorthand for it. So that's what a toxin is. And I said, you notice that I said a substance that is created by a plant or animal. So it's a natural substance that is poisonous to humans and other living things. So poisonous, that is a thing, but poisons and venoms are two different things. However, you could still say that a venom venom is poisonous, but it is not a poison.
AKA, so that sounds super confusing, but think of it this way. For the catch-all, all right, think of it this way. I was always told, venom, you are being injected by something. Poison is you are ingesting. So if you bite something, it's poisonous. If it bites you, it's venomous. So snake, venomous, not poisonous. And I will correct people every time they say poisonous snake. Sorry, I can't.
It's one of my biggest pet peeves.
I can't do it.
Thing that I always correct people on, and I'm so proud because I even heard my husband correct someone, and I was like, or my biggest one is not even when people say it; it's when I read it in a book, and I'm like, dude. So the author didn't know, the editor didn't, nobody.
So many people, so many people didn't know.
But yeah, so just all another confusing way, all toads are frogs, but not all frogs are toads. All venoms are poisonous, but not all poisons are venoms.
Isn't it all squares are rectangles, but not rectangles are squares?
All right, you lost me.
You're talking to two people that avoided math at all costs. You went to an insanely expensive undergrad just to avoid math classes.
So Katie's gonna cover poisons, and I'm gonna cover venoms. So Katie, you want to take it away and tell us what a poison is?
Yep. Okay, so Laura gave you a little bit of this, but poisons are substances that can cause death, injury, or harm to organs, tissues, cells, and DNA, usually by chemical reactions or other activity on the molecular level. And typically it has to be in larger doses, but again, you'll find out that some of these, it does not take much. So basically, if you can ingest it, like I said earlier, or if it can get onto your skin or through cuts, and you get a reaction from it or sick from it, it's a poison. Any toxin found within nature is referred to as a biological toxin or biotoxin. Biotoxins can be conveniently grouped into three major categories. 1, microbial toxins, poisons such as caused by bacteria, blue-green algae, and golden brown algae. 2, phytotoxins, poisonous produced by animals and plants. And 3, zootoxins, poisons produced by animals. Wait,
you just said animals and plants for phyto. You mean just plants is phyto?
Oh, sorry. Yeah, phyto is poison produced by plants. And 3, zootoxins produced by animals. Sorry.
Gotcha.
So, like most species diversity, poisonous plants and animals are found in the greatest abundance and variety in warm, temperate, and tropical regions. Just like everything else that can kill you. Very few toxic organisms are ever found, there's that band, and the species that I'm going to talk about for the most part stay within that band as well, but above the equator. I forget how far it is, but it's that middle band.
The belt, the what is it, Tropic of Capricorn or Cancer?
Yeah.
Between the Tropic of Capricorn and Cancer, I'm pretty sure that's that belt.
And so that's pretty much where we have the most diversity of species in general. That's pretty much where everything can kill you. Because most aren't found outside of that. Are there? Yes, absolutely. It's poison. There's going to be stuff all around that can kill you, but for the most part, it's going to be within that band. Although we know a lot of stuff within nature can poison us, scientific understanding of how poisons have evolved is poorly understood. So as you said earlier about they studied venom and the evolution of venom, as far as poisons go, not all that studied as far as evolution where it goes. I
believe it. Well, because where do you even start?
I know.
It would be so hard.
Could not. I would not even know.
Because there's evidence of, as I'll talk about, there's evidence of venom because venom glands are a thing.
Yep.
It's an organ that an animal has. But a poison is just how there's no fossil record of a poison, I would assume.
Yeah. No, not most of the time. So some of them do have glands where it would secrete like a frog, but a lot of it too, it is like plants. It's just another chamber. How would you even know that chamber is used for poison and not moving water? You wouldn't. You would have no idea. So organisms could have evolved to have the poison to help them to eat, break down, or killing prey, or as a defense mechanisms. And humans, if you think about it, really haven't been around all that long in the grand scheme of evolution. So animals and nature in general have adapted for survival, yes, but survival in general, not specifically towards humans per se.
Oh, yeah, for sure. Not just us, yeah.
Yep. And so microbial poisons are produced by, I think I said this a little bit earlier, but the bacteria and blue-green algae and protista, which we had an episode on that. And so that kind of breaks it down a little bit.
Green algae in our extreme episodes.
Yep.
They live in extreme places.
Yep. And fungi. And I'm not going to go into any further detail than that because holy moly, it gets insanely detailed. So basically just know there's a lot of crap out there that can kill us. Anything from tiny microscopic things to larger animals. So in a very, very, very small nutshell, that is poison.
Gotcha. Yeah, I mean, definitely we're going to have to do future episodes on poisons and on venom so that we can, break things down further and further because there's a lot of cool content to talk about. So on the heels of poison is venom. And just there are charismatic megafauna that get all the attention when it comes to animals, definitely I feel like venoms are, the cool thing. I mean, poisons are cool. But, like, everybody knows and
Venom.
are afraid of venomous animals.
Yeah, and people don't... Well, I mean, even though they call them poisonous, it's venom.
Right. Right. So, as we had said earlier, venom is a poisonous substance injected into prey or predators. Typically, this is done via a bite or a sting, but sometimes it's with some other things. It's an active action rather than a passive one. So, like, poisons, it just passively, like, you ingest it. It's not deliberately trying to poison you, kind of. Venom needs to enter a wound. It needs to get into a bloodstream to have any effect. So, theoretically, you could eat venom and you'd be fine if you didn't have any cuts in your mouth or your stomach or anything like that. So, I would not recommend...
Yeah, theoretically. Yeah.
Theoretically. So, venoms are essentially chemical cocktails of enzymes and proteins. They serve as a way to subdue and kill prey, as a defense mechanism, or as digestive fluids. So, animals use venoms in many different ways. There are actually about 100,000 venomous species, which I had no idea there were that many.
How many?
100,000.
Okay.
So there are 100,000 species out there that could mess you up. The oldest known ones are jellyfish, which came about 600 million years ago. And their venom in general is thought to have evolved when copied duplicate genes mutated. So, like, when your genes are replicating, sometimes they just duplicate themselves. Some of them may have mutated and made those proteins toxic, and then also ended up with something called a venom gland, which holds that stuff. This new function...
Okay, hold on. This still, like... This is why evolution just baffles me.
Yeah.
Because even if you, like, your body figured out venom... It's like, you know what I need? A gland. Like, right, to hold, I need something to hold all this.
Yeah.
Yeah, right? That's our, forget the chicken and the egg. The gland of the venom. What came first?
The gland of the venom. This new function of an old gene is called neofunctionalism, which I think is kind of a cool term. So, as with many things in nature, this venomous predator versus prey thing has become an arms race, with each continuing to adapt and change to one another. So as one animal becomes venomous to eat another, that animal gets immunity, and then the venom changes, and then that animal changes, and then the venom changes. So it's like back and forth, back and forth, back and forth.
A race of survival. I want to kill, and I want to live.
Right, exactly. And that's like that with pretty much everything, but venom is no exception. So certain venoms can be more effective against certain groups of animals than others. So some venoms are only meant to target mammals, and some are only meant to target reptiles. They can be very specific. Some can become more potent over time in this arms race, while others completely disappear depending on selection pressures. So, like, if venom is no longer needed... So, for example, was this one type of sea snake. It used to eat these fish, and it needed to kill those fish very quickly. But then it started eating eggs, and you don't need to do that to eggs, so it just became non-venomous.
Again, though, it's like, you know what, I don't need this. Let me just get rid of this entire defense system that my body has evolved over years.
Yeah, so it can go one way or the other. Also, crazy fact, as with all things, any trauma... affects your DNA. Like, if trauma happens to me, my DNA is affected. I then pass that affected DNA on to my offspring.
What classifies as trauma? Do you know? Like, did it say anything?
Well...
Like, how traumatic is traumatic?
Probably not crazy. Like, seeing somebody getting bitten by a snake and possibly dying is enough. Because they believe that fear of envenomation is inherited. So you were born being afraid to be bitten by snakes. Especially if your family has a history of that happening. They did that experiment with, like, baboons. Like, baboons are, like, they are born knowing to be afraid because their DNA was affected by, like, a parent or something. I don't know how many generations it goes along, but there is stuff called, like, generational trauma. So, like,
true.
You know, Holocaust victims and their... Anyway, and so last but not least, before I go into a little bit more specifics, is there are at least 4 classes of venom, just as there were 3 classes of poisons. So the 4 classes of venoms are neurotoxins, which target your nervous system, hemotoxins, which target your blood, myotoxins, which target your muscles, and then cytotoxins/necrotoxins, which target your cells. And
between neurotoxin and hemotoxin, I honestly don't know which I would rather die by. This is like, would you rather be burned alive or drowned? Like, I don't,
right?
I don't want either one. It's either your nervous system or, like, do you want to see, like, holes in your body?
Yeah, because the neuro one is going to target your nervous system, so that's going to make you, like, stop breathing or have seizures or be paralyzed. Same with, like, the muscles can affect, like, muscle twitching and paralyzation. Hemotoxin can either, like, make you bleed to death or coagulate your blood and it's turned to solid, and affect, like, your cardiovascular system. And then the cytotoxins and necrotoxins explode your cells and cause mass damage.
That's just such a bad way to go.
Yes. So, I mean, theoretically, for the most part, venomous animals are like that to kill prey. And they want to be really effective about it because the faster they kill their prey, the less damage gets done to them. So, you know, it's not like they had people in mind when they were developing their venoms. They were thinking of their prey and they wanted it to die very quickly so that they didn't get hurt. And then some are for defense. And also there are, okay, I'm sure there's a huge debate here about are there or are there not venomous plants, okay? I think it would depend on who you ask, because I think technically yes, because it's injected. Some people would say by definition no, it has to be an animal. I don't know why. But, so I would say yes.
But there's like the stinging heart, like the stinging,
right. So the one we've already covered, if you guys want to hear more about a venomous plant, in our plant defenses episode, Katie talked about the gimpy plant.
Yep.
Venomous. And it's in the stinging nettle family. Anybody who has been stung by stinging nettles, they've got like little things that inject poison into you.
Yeah.
And it can be very, very painful. Okay, so that's venom in a nutshell, like you were saying.
Alrighty. So now we're going to give you two examples of, I think we covered one of mine, but I'm going to give you one example of poison. I picked two of the most poisonous things that you could find on the planet.
Cool.
The first one I picked...
That's what everyone's going to want to know.
Right? Is what can kill me the fastest. So the first one I picked was water hemlock.
Dude, that is...
everywhere here.
All around my
yeah, right?
All around like, literally grows around the building. And I picked it one day because I thought it was... yarrow, because it was in the carrot family. And
and I'm going to get into that, too.
Straight up panic attack. I had to go take a walk in the woods and calm myself down because I was shocked.
I am going to die. Yeah, we all know how Laura is. If you didn't listen to our Brains episode, go back and listen about how Laura can't handle... I mean, I don't blame you, but go back and listen. Yeah, you'll understand.
Well, and too, like, it's that dang internet, man. I looked it up and I was like, okay, yeah, sure, you gotta eat it. But then some people are really allergic to it and all they have to do is touch it. And I was like, what if that's me?
What if that's me? Alright, so water hemlock. So it's the first poisonous thing that I'm going to talk about. Water hemlock or spotted or poison hemlock. There are a little bit of a variety of a difference, but they're all basically the same plant. Is the hemlock that killed the ancient Greek philosopher Socrates, which I did not know that.
Is it?
It's a relative of it. It's a relative of it. Yeah, it's still within the hemlock group. So let's see here. So this water hemlock, the one that I'm going to specifically talk about, is just the one found here in North America. So its toxin, which is called toxin, can cause delirium. Listen, all I know is don't touch it. But it can cause delirium, nausea, convulsions, abdominal pain, seizures, and vomiting within 60 minutes of ingestion, which frequently leads to death. But on a positive note, the toxin smells like carrots.
Because
it looks like it.
In the same family.
Yep. Yeah. So water hemlock is considered to be the most poisonous plant growing in North America. And where in North America can this be found? Like we said, basically everywhere. Water hemlock.
It's all over. It's definitely all over. Mm-hmm. And it's pretty. So a lot of people, like, it looks like Queen Anne's lace.
Oh, I'll go into the description because I'm sure people have seen this and been like, oh, crap. All right, so water hemlock grows in marshy, swampy areas of meadows and along banks of streams, pools, and rivers. Water hemlock has small white flowers that grow in umbrella-like clusters. Side veins of the leaves lead to notches, not to tips at the outer margin, which is basically just fancy botany terms. But if anybody out there is really into plants, they'll know what I'm talking about, which I really like plants. Anyway, so let's see here. There has a thick rootstock of water hemlock, contains a number of small chambers. Again, like we were talking, like the fossil. Like you would never know, finding that in the fossil evidence, that all these chambers. Anyway, so in those chambers, they hold tightly poisonous brown or straw-colored liquid that is released when the stem is broken or cut. Thick, fleshy tubers and slender individual roots grow from the bottom of the rootstock, and water hemlock grows in wet seepage areas of meadows, pastures, and streams. Basically, if it's wet, it's growing.
So, and it doesn't have to be that wet either, because it's all around in our gardens, and they're not that wet.
Yeah. And it can reach a height of 0.5 to about a meter tall, so 1.5 to 3 feet taller-ish. And like Lori said earlier, it is a perennial in the carrot family. So accidental poisonings usually occur when water hemlock is mistaken for edible plants such as artichokes, celery, sweet potato, anise, or wild parsnip.
I could definitely see like the parsley and the carrot could be a mistake for sure. They look a lot alike.
Yeah, no, they do.
This is why you do not forage.
Yeah,
unless you are an absolute expert.
This is why. This is definitely why you shouldn't. Into the wild, how he eats. We talked about that in the nature hotties.
Don't do it.
Just
guys.
don't do it, guys.
Do it unless you've went to school for identification,
right?
Or something like.
Yeah. So because all parts of the water hemlock, every single part of the water hemlock is toxin and can cause death within as little as 15 minutes. So average is about like 60 minutes that you're going to see death, but you can start to see symptoms, which will lead to the death in as little as 15 minutes. Typically, the first symptoms you're going to see are drooling, nausea, vomiting, wheezing, sweating, dizziness, stomach pain, like red flushing of your face, weakness, tiredness, delirium, uncontrollable bowel movements. So you're just like...
Just wrecks your body. It wrecks your body.
But I just picture like wheezing and just like the squirts out your pants. It's just a horrible way to go, man. Like, no... All of them touching a plant, like... that you thought was celery, like,
and well, from eating it typically, but like I said, it
can't. No, if you touch it, you can be a downer.
I took a walk for 60 minutes because I figure once I was past the 60 minutes,
then you were good.
Okay,
you're probably good. So all those symptoms are followed by the more serious symptoms, including trouble breathing, convulsions, heart problems, kidney failure, coma, and death. As poisonous as it is, though. And every website was as shocked as I was to find out that it can be used for medicine. Some people use it. Every website was like, shockingly, surprisingly. And I'm like, yeah, who would have thought? But apparently, there's not a whole lot of research into this, but people have claimed that it can help with migraine headaches, painful menstrual cramps, bronchitis, asthma, intestinal worms, which, yeah, of course, if you're gonna be blowing out your pants, it's just kill everything in your digestive system. But skin redness and inflammation and several other conditions. So,
did you come across, like, just speaking of this, surprisingly, when you were doing your stuff, did you come across the quote by Paracelsus?
No, I didn't.
Okay, so Paracelsus says, it is only the dose which makes a thing poison. Which is, if you, sometimes you don't, it's just about how much. So, like, if it's not a ton, it could possibly be used as a medicine.
I still wouldn't risk it. I mean, I know,
no, absolutely not.
But at the same time, it's like, you listen to those commercials about, like, the medicine, and it's like a list of side effects that are like, hey, you have a headache, take this medicine. Also, it can kill you. Like...
Well, right. The first part of his quote is, all things are poison, for there is nothing without poisonous qualities. Truth. Even water can kill you.
True.
Just depend. It's only the dose which makes a thing a poison.
What was that politician that, like, did a whole spiel on dihydrogen monoxide or dihydrogen... What is it? That did it on water because he didn't... Like, somebody slipped it to him, thought it was funny, and he didn't catch on to it. Yeah. Well, anyway, guys, that was water hemlock.
Water hemlock. Yeah, man, that no joke. And there's a ton of accidental poisonings, too, by, like, pets and children, because they don't know any better either. So it's like, man, so there is a group that I belong to on Facebook, and people post pictures on there a lot of, like...
Just random stuff? Or just
things
plants?
in their yard. It's all nature.
Okay.
It's nature in the area. And so sometimes people will post pictures of, like, plants in their yard that are possibly, like, toxic.
Uh-oh.
And people... There are two factions. In this group, there are, like, extremists. So one side is, like, absolutely pull that from your yard. Freaking now, it can kill everything and your children and your pets and all this stuff. And then the other group is, like, leave it where it is. Education is the key.
Oh, my God.
And and so then, like, it's just, like, eating popcorn watching these people argue. I think within reason... I mean, I'm definitely in the middle ground here. Like, should you rip up everything? No, because then you wouldn't have a yard left. Because, again,
just
like,
keep ripping up your yard.
Things. But, like, you should talk to your kids as early as possible about don't
eat crap. Yeah, don't put it in your mouth. Just don't put it in your mouth.
Put it in your mouth. Because even if it's not, I was holding my mom's hand when I reached down and ate a poppy, which
oh my gosh, yeah.
And I was holding her hand. There's nothing, like, it doesn't matter how much you know, within reason. But, yeah, water hemlock, that's scary stuff. Oh, also, fun fact, it smells like mouse urine, when you pick it.
Water hemlock?
Say it's definitely musty. Yeah, mouse urine is a known, like, smell.
I heard it, well, it said in here, everything I saw, it smelled like the roots smell like carrots.
That makes sense. It's just like the stem, like it smells like really nasty, musty, and some people say the smell is mouse urine. I don't really get the pee smell from it, but it definitely smells musty. Okay, so for my first venomous animal, I'm gonna do the platypus.
Yay!
Because everyone is like, look at those cute little platypus.
It will kill you.
And they're actually venomous. Yeah, actually, like, everything about the platypus is just, it's an unreal animal. Like, if I didn't know it existed, it'd be very hard to convince me that it did. Because it's a mammal that lays eggs, that has a bill like a duck. It doesn't have any nipples, although it lactates. It doesn't even have a true stomach, which I just found out today. And it's venomous. Like, unreal. So, a couple things about the platypus. Well, first of all, I'm not really going to give much natural history. Most people know what a platypus is. But it's a mammal from Australia. It lays eggs like a weirdo.
Lays eggs like a weirdo.
It's really cute and small. But what makes them venomous? So, first of all, only males have the ability to be venomous, which is cool. Although females do have, so they're venomous because they have these things that look like spurs on them. Females have vestigial ones, meaning like tiny little ones that don't work when they're born, but they lose them within their first year of life. They are using them for defense and for fighting, mostly for fighting. So this whole system, it's called man, try and say this word, Katie. Crural.
Oh, listen, you know R's and L's. I can't say.
I mean, rural. It's rural, but with a C.
Curl.
It's a crural venom system, which means it's relating to the leg or thigh. And so it has these hollow spurs on their hind heels. So they're like little cowboys. They have spurs on their heels.
Okay, pause. That just made it way cuter. They're like little cowboys. Right.
Again, I want Josh.
Yeah.
Now I need a
cowboy platypus. That's so cute.
Yeah. And just walking around, cha-ching, cha-ching, cha-ching. Instead, there's only room for the one of us. Yeah. But so instead of having like round spurs, though, like a true spur, these things have like rooster spurs, which are just two spikes on their feet. They look terrifying. And their venom glands are located on their back beside their tail. And each venom gland can hold about 4 milliliters of venom, which is not a small amount, really. However, venom is only seasonal as it's used during mating season.
Oh, I didn't know that.
I had no idea about this.
Yeah.
I had no idea. So, yeah, it's only a seasonal thing. Those venom glands are empty until the breeding season starts, and then they fill up. Because they're using them for fighting, like roosters use their spurs.
Yeah, interesting.
But instead of, like, the roosters just fighting with them, the platypuses took it to another level and just stab the crap out of each other and paralyze each other.
That's so... do they recover or no? Is it, like, death?
Yes,
okay. So it's like recover. A stun.
It's not deadly to each other.
So it's just a stun.
It's just like... Gah, 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 gah. So what they do is they wrap their little hind legs around their opponent, like put him in a leg lock, okay? And then just... Gah, 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 stab them with their spurs. Then the other one just starts twitching out and gets paralyzed while the victor gets the lady.
Australia, man.
Yes, it's a lot. So, like I said, it doesn't kill them, and it doesn't kill people either. At least it hasn't so far. It has killed dogs, which is kind of interesting because you'd think then, like, maybe it's all mammals.
Yeah.
But it doesn't kill the platypuses. So, anywho, so their venom contains 3 major toxic groups, which I'm not going to go into because it's all chemistry stuff.
Wait, their venom contains 3 different ones?
Yeah.
Oh, interesting.
Yeah.
Cocktail.
3 different toxic groups. Yes, a cocktail. So what does it do? Their venom disrupts blood regulation, destroys cells, and disrupts pain regulation. Which means that causes swelling, cold sweats, muscle wasting, nausea, and whole body pain that can last for weeks.
Jeez, that
weeks,
sucks.
Katie. Weeks
that sucks. No thanks.
Like that gimpy plant, only not that long. But, so the muscle wasting, let's say you get, you're picking up a platypus because you're dumb and you're trying to pick up one. So you pick up one, it spurs you in the hand. Your hand may atrophy, the muscles waste away, and sometimes it never comes back. Like, some guy has never recovered the use of his hand completely because the muscle's all, like, degraded. The pain is intense. One Vietnam War veteran said it was worse than shrapnel. And
jeez.
It cannot be treated by morphine. The only way it can be treated is with nerve blockers, so localized.
Oh my god, yeah.
The only way you're getting.
Basically they just don't let you feel that limb. That's what makes it feel okay.
Yeah. Okay, so as horrible as that is, like I said,
there's a bright side.
And with most venoms, there is a bright side because a lot of venoms are researched, and we're trying to find medical uses for them. Downside, there is no antivenom for platypus venom because I guess it happens so rarely, like they're like, what's the point? Or something, I don't know. But there's no antivenom for that. However, there are, because of the way that it can overcome morphine, there is possible pain management implications. Like if they can figure out how the venom does it, then they can maybe figure out a way to like make better painkillers. And they have discovered that it contains a hormone that may help treat diabetes. Because essentially, part of their venom is weaponized insulin, which other animals use insulin as a weapon too.
Yeah.
But yeah, they specifically it contains like an insulin regulator. So they're trying to. I mean, it's going to be years before it can ever be used as a drug, but they know that it could be. And that's the platypus. Don't cross one. At least during mating season.
Or, yeah.
Don't cross a frisky platypus.
A regular platypus, okay.
On a t-shirt.
Yeah, don't cross a frisky platypus.
Don't cross a feisty platypus.
Oh, that's amazing. All right.
Definitely, yeah. And on that shirt, just for me and you, on that shirt would be a cowboy platypus, like menacingly holding up its leg that just says there's only room for
one of us. That's awesome. All right, the last one that I'm going to do, the second one I'm going to do is pufferfish. All right, the grouping of pufferfish. So, pufferfish, or the Tetradontidae, it is the family of primarily marine and estuarine fish of the order Tretodontiformis. It just...
Why do you even try?
I don't know. I feel like it's relative information, but it's just so horrible every time. Not that anybody really cares. I mean, some people I guess do, but most people don't. Anyway, so the family includes about 120 different species, many familiar species variously that are called pufferfish, puffers, balloonfish, blowfish, blowies, bubblefish, glowfish, swellfish, toadfish, toadies, turtle, honey toads, sugar toads, and sea squall.
Oh my gosh. I do know. There's a guy on TikTok I follow who has a pufferfish, and it's so cute.
Mm-hmm. They are pretty cute.
And it gets pretty, when it gets mad, it spits water out of the, like, into the air.
Yeah, that would be,
yeah.
I mean, I need to do that. I get mad, just spit water. Anyway, so they range in size from about 1 inch long, the dwarf or pygmy puffer, to the freshwater giant puffer, which can...
Pygmy puffer.
Which can go, the giant one can grow more than 2 feet in length, which is pretty dang big. They are...
That's a substantial fish.
Right? They are scaleless fish and usually have rough to spiky skin. Of course, you know, puffer, spiky. They also have 4 teeth that are fused together into a beak-like form. And if you've ever seen some of these, like, puffer fish with, like, the really predominant beak, they either look like they have buck teeth and, like, super dorky, or just, like, I don't know. They're just, like, real dorky looking. They're pretty funny. But the puffer family, the Tetraodontidae means 4 teeth, which I figured you could have thought of a simpler word for 4 teeth. But anyway, the puffers use those 4 teeth to crunch hard marine shells of mussels, clams, and even crabs. So pufferfish can live on vegetarian diet of algae, but they prefer meaty crustaceans when available. Which, I mean, can you blame them? Algae or, like,
no,
crabs? I mean, come on now.
Right.
So there's the 4 teeth on the top and bottom of the puffer's mouth that fuse into the plates, and they get the name pufferfish because they puff by sucking in tons of water or air, if out of the water, because they can be out of the water and inflate, into their elastic stomachs. This behavior is simply to intimidate predators. Since puffers aren't particularly fast fish, they rely on scaring predators rather than swimming away. So instead of they already know they're slow, and so instead of just attempting to escape, they just puff up because they're like, you know what?
That's smart.
I'm not fast. Let me just puff up instead. A pufferfish reaches sexual maturity at the age around about 5. Which is a lot older than what I thought, because, like, a fish living to 5 years old, that seems kind of old to me. You know what I mean? But anyway.
Yeah.
The average lifespan of a puffer fish is approximately 10 years, so it's got to wait till half of its life before it reaches sexual maturity, which is crazy. So anyway, most of the variety of puffer fish are found in the tropic and subtropic oceans. Again, it's that band around the equator. But there are 35 species of pufferfish that live in brackish and or fresh water, which is pretty interesting. All right, so the poison. So in particular, they rely on the potency of the toxin that they produce. Puffers kill people around the world every year with their deadly tetrodotoxin and are the most poisonous fish in the sea. But they aren't toxic unless you eat it, and leave it to humans to eat something that can kill you.
Leave it to humans who would eat something that's covered in spikes
and kills you. And they're like, you know what? I feel like I need to eat this. Like, there are how many other fish species?
How did that even happen by accident?
Yeah.
Because it's covered in spikes. Why would that be? That would be the last fish that I would try and eat.
Right? 'Cause just the hassle of taking the spikes off, if anything. Anyway.
Yeah.
So it's the liver, the intestines, the gonads, and the skin are all highly poisonous and can cause death in around 60% of people who eat it. The toxin is said to be more than 1,000 times the strength of cyanide. Like, yeah, so it's not even like a little poisonous, it's insanely poisonous. I think they said like a little bit up from a pufferfish is enough to kill like 30 people or something, I think I read. And there's no known antidote. So, like, you eat it, you're just gonna die.
That's it.
But that's it. So, in Japan, though, there's called fugu, I think it's called. And they are expensive, delicious treat, like the puffer fish is what this is called. They are prepared by trained, licensed fugu chefs, and it can be obviously poisonous to humans due to the tetrodotoxin. And so it needs to be carefully prepared because obviously if you cut something and contaminates the meat, whoosh, your customer is dead. And obviously that's on you. A lot. So apparently. So there, I mean, it's very, very controlled in Japan, and several other countries, and only chefs who have qualified after 3 or more years of rigorous training are allowed to prepare the fish. So, which just blows my mind. All right, so what happens? Those that eat the pufferfish, symptoms generally occur 10 to 45 minutes after eating the pufferfish poison and begin with numbness and tingling around the mouth, salivating, nausea, and vomiting. But symptoms can rapidly progress to paralysis, loss of consciousness, and respiratory failure, which will eventually lead to death. So if someone does have symptoms, they often induce the vomiting if the the person who ate the poison is awake, alert, and has eaten the fish within 3 hours, which that doesn't add up to the timeline, but anyway. So if they don't induce the vomiting, the person quickly will become paralyzed, and others have said to help with artificial respiration. But basically, if you don't vomit, you're basically screwed. Because again, there's no antidote.
Jeez. But right, like, what are the chances of you even knowing that you ate it? And until your tongue starts going numb, and then and then is it too late?
Numb, yeah. Just start vomiting. And that's what they said, like, once your tongue starts going, like, once you start to experience symptoms, just throw up. Like, it's too late. Yeah, right? Too late. Well, but fun fact about pufferfish, they're the only bony fish which can close their eyes. Who knew?
They can blink. They'll wink at you before you die.
Yeah. Oh, do you remember that whole conversation we had? I think we actually had that conversation here on the podcast too. Whenever I was saying about can you wink both eyes at the same time, and you were like, you mean blinking? I don't even remember what brought that up, but I just remember feeling like the biggest idiot. You can wink with both eyes. You're like, you mean blinking? We definitely had that conversation on here too.
What was I going to say? Oh, so what's the point of a pufferfish being poisonous? Because, like, you'd think it'd be a defense, but, like, if it's, like, isn't it too late?
I think if like something were to chomp down on it and it would like puncture its skin enough, because its skin is poisonous too. You know, even though it has the spikes, like that's defense mechanism 1. 2, if you do for some reason get a part of it that isn't covered in spikes, the poison will get you then. Like, so it is defense. Like
self-sacrifice of the one, so that like the animal learns it's less like, because I feel like if it's gonna take minutes, you're probably already eaten. But like then all of your other brethren,
yeah,
don't get eaten.
You're the martyr, pufferfish.
Martyr pufferfish.
Everywhere! He's just being eaten by a shark. Oh, but was it shark? Hang on, wait. Fun fact though, shark are the only ones. I thought I said this, but maybe not. Shark are the only things that are immune to their toxins, surprisingly enough. Yeah, only shark. They don't. Yeah, it's just sharks. Everything else, it'll die from it. Sharks, nope.
Those sharks. Well, I'm gonna stay in the ocean. Because the ocean's a scary place and it's full of toxic things. And if not pufferfish, which are poisonous, if they don't get ya, then the box jellyfish will. So specifically the Australian box jellyfish, the more you look up about venomous things, the more you realize, like, everything in Australia. I mean, as we've already talked about, we talk about Australia more than, like, anything else. But that's just because Australia has some crazy nature stuff.
They do, yeah. So I'm telling you, that's the only country I've ever been to where I actually teared up when I left it. I didn't even tear up when I was leaving America. Like, Australia now, I was like, I don't want to go. Because it is really cool, diversity. Yeah, I mean, it was awesome, but it was awesome. I mean, a cassowary, listen, I'll go back.
So the Australian box jellyfish, aka the sea wasp, which is a cool nickname, is arguably the most deadly venomous animal, and if you're not going to say that, then it's definitely the most deadly marine animal. So, and with poisons and toxins in general, you know, I think if people are like, well, what's the most deadly venomous animal. Well, that's depending on, like, are we talking about potent? Are we talking about how many people it's killed? Like, this kind of thing. So this isn't the most potent, but it is very deadly in that, like, most people die from it if they get hit. So there are many species of box jellyfish. Not all of them are lethal to humans, but the Australian box jellyfish is insanely venomous. It is a squarish-shaped jellyfish, which is why it's called a box jellyfish, with around 15 tentacles. Their body is about 1 foot in diameter, and their tentacles can be 10 feet long.
That's insane.
It's so long.
I feel like that's excessive. Like, again, going back to the evolution thing, what is it, 7 feet? Not long enough. You know what I mean? Like, 8 feet, still not long enough. Like, must be 10.
10 feet. Each tentacle is covered in 5,000 nematocysts. Okay, which doesn't sound that scary until you know what a nematocyst is. So a nematocyst is basically a tiny little hypodermic needle that injects venom whenever it's touched. It's like a spring-loaded injector. So 5,000 spring-loaded injectors on each of these 10-foot tentacles, and there are 15 of them. So,
just not even, like...
a lot.
That just sucks, yeah.
Yeah. So, and their venom it's got a lot of stuff in it, but what makes them kind of so deadly is people swim into them because they don't see them because they're see-through. So
like glassy?
See-through. Yeah, like they're like glassy looking. So a lot of people don't see them until it's too late. Also, like, just unfair. These jellyfish can swim and see, which is not normal for jellyfish. Normally, jellyfish...
They can see?
Yeah. Normally, jellyfish just, like, float along, doing their own thing, going where the current takes them. Nope. These guys swim where they want to, and they actually have eye clusters. Scientists don't know how they process vision because they have no central nervous system. So how...
Yeah, they just have a neural net, right? They don't have a brain, they just have a neural net.
Somehow they're using vision, and they have, like, advanced vision. It's not just, like, light sensitive. They have, like, a lens and an iris and a cornea and, like eyes.
Maybe they're still developing their eyeballs.
Maybe
we just caught them in the middle of an adaptation development.
Who knows? And so scientists think that this means that they must actively hunt for their food, which is shrimp and fish. So they're out there hunting, being insanely venomous. So what happens if you do swim into one? Well,
like Rambo.
You are you are wrapped in 15 10-foot long tentacles, like just trying to like get your way out. You're like in a net of tentacles. They're wrapping around you and they're stinging you and stinging you and stinging you.
Gosh.
So what happens when you're stung? Necrosis, which is tissue death. Paralysis. Hypertension followed by hypotension. So hypertension followed by low blood pressure.
Yeah, right? Suddenly you're like, oh, wait.
Your heart doesn't know what to do.
Gosh.
Cardiovascular collapse. So your like veins and stuff collapse. Cardiac arrest. Pain and death. All which happens within minutes. It holds the world record for
Jiminy Christmas.
You can die in 3 minutes.
Which is not... I knew that. I knew it was, like, quick.
Yeah,
like
it's so fast. And the only, like, silver lining is if 10% or more of your skin must be injected. So I guess that's not really much of a silver lining.
Well, it kind of is, because you would really have to be wrapped up.
Yes.
And let's just hope that if you started to feel it, you could swim away... Yeah, and not swim into it.
Yeah.
Like, here's hoping you know what direction, you know what I mean, and go back where you just came from. Dang.
Yeah. Because, once more than 10% of your skin is covered, your body just can't handle it, because it's all, like, that is all happening localized, and so it's just happening localized all over your whole body, and your heart can't take it.
Dang.
And they can leave, like, this happening to you can leave permanent scars. They look...
I have seen pictures of scars, yeah.
Yeah.
Yes.
Like you'd think, almost like you've been electrocuted by these tentacles.
Ugh.
So their venom is, of course, a cocktail, because what's happening to you is both neurotoxic and hemotoxic and necrotic and, like, all of it. It's all happening in your body. Good news is there is an anti-venom. If you can get it in time. It's just that a lot of times people, like, seize up before they reach shore and then just drown. So if your heart attack doesn't kill you, you might just drown. But if you're around other people, which hopefully you're swimming with others.
Always should be swimming with others.
Alone.
Yeah. Or hike alone or anything.
Right. There, if you can get it, there's anti-venom, and even better is that there's actually, they've developed a medication that can both stop the venom as well as reduce pain and scarring if it's used in the first 15 minutes. So get to shore and get the...
As long as you don't die within 3 minutes, like...
Right. As long as, yeah. And again, another, like, silver lining is, you know, just like all the other venoms, these ones are being researched. So, again, pain management implications, if they can figure out how they can cause so much pain, that they can hopefully harness that. They also think the same thing about treating heart complications. If this is so targeting your cardiovascular system, then perhaps it can be targeted to, like, help overcome cardiovascular problems.
Interesting.
And then for sure that they know that it can be used, there's an antibacterial property of their venom, which has been shown to kill some antibiotic-resistant bacteria, which is pretty cool.
Interesting, yeah.
So, yeah, the box jellyfish, do not go swimming where you've heard that there's one. There's lots of ways to avoid this happening to you. Don't go swimming where there are box jellyfish. And, like, always be aware of where you're swimming and don't swim alone. But I feel like the platypus is a little easier because you just don't mess with a frisky one. Don't pick it up. Yeah. The box jellyfish, you could just be swimming and minding your own business.
Yeah, minding your own business. Yeah, and then die. Yeah, just don't touch a frisky platypus. Yeah, you're golden.
One thing from this episode, just
don't touch a frisky platypus.
So with all of this being said, you know, there are lots of poisonous animals, lots of venomous animals. I'm thinking that, like, maybe we can break this down into, like, venomous or poisonous plants.
Oh, we definitely could. Yeah, we definitely could break it down more if we didn't want it to.
And if you are interested, we should also try and find a venomologist, because that is someone who studies venoms. So cool. There's the one they were talking about trying to find stuff for box jellyfish. There's a guy who's just discovered how to milk a box jellyfish. Or jellyfish in general, because it's hard.
But I don't know if that's like, how do you put that on your resume? Like,
milking a jellyfish.
Yeah, I can milk a jellyfish.
Nipples.
Yeah, right. Did he have to find the nipples? Like, did he try to find the nipples?
Yeah, apparently. This is a total side note, but so, like, you know, you can. I think the old way that they would milk jellyfish is basically, you know, just like make them hit something.
Yeah.
This guy figured out that if you dip, like, a tentacle in like, ethanol makes the nemesis release. So that's why you never put alcohol on a jellyfish sting, because it will only make it worse.
Yeah.
So if you put the tentacles in ethanol, then the nematocysts release, and you can immediately capture the venom. So he is overcoming the barriers to milking jellyfish.
I didn't ever know that was a barrier we had to overcome, but apparently so.
He's a venomologist, which is such a cool job. Like, what a cool job.
That is a pretty neat job. But also dangerous, like,
oh my god.
You know what I mean?
Yeah.
Like,
don't mess up.
Yeah, ever.
Like any of the poison things either. Yeah.
But still, like, my job has a very high margin of error. Like, you know what I mean? Like, I can really mess up and I'm still okay. Him? Like, nope, cannot. Dang.
Yeah, he forgot to wear his gloves one day, or forgot,
Or he just sneezed funny. Like, man, goner. Alright, folks. Well, that was Venom and Toxin. And like Laura said, we're probably going to break it down in future seasons, just because there really is a lot to go into. So if you guys liked it, or if you have a favorite, I mean, that'd be interesting if people have a favorite venomous or poisonous plant or animal.
Like, what to cover first.
Yeah, let us know.
And guys, this is the second to last episode of the season, and the last one you're going to hear my voice on before the season ends, since the next one, it's going to be Katy's awesome interview with some really cool people you're not going to want to miss.
Oh my gosh, it is. Oh, that's heartbreaking. I mean, not really. So if you guys, it means Laura and I get a break, because we do have a break in the season, but we're still going to be releasing episodes because Kim, our amazing manager, is going to be doing mini episodes. So make sure you guys keep listening. We just want to keep the momentum going because we are picking up a lot of momentum. And so we want to keep the ball rolling on everything. So keep listening, and you guys will be hearing from Kim next week. You get a little bit of a break from us to go to Kim. And Laura and I have looked over what Kim is doing.
Solid.
Be excited. Guys, just be excited. Kim's amazing.
It's relevant to everyone, and the way that Kim talks is so entertaining,
it's
too.
So entertaining.
Kim's definitely just as funny.
By herself, she's funny. Like, she doesn't need a co-host. She's just funny in herself.
And so we promised you at the beginning of the season that we were never going to stop again, and...
We're never stopping.
Never stopping.
Yeah, never ending. We're just going to keep giving you useless animal facts and nature facts.
You'll hear from us in season 6.
Till next season, everyone.
Bye.